Okay, para sa part 6 ng lecture natin para sa cost concepts and design economics. So, doon na tayo sa cost-driven design optimization. So, sabi dito, engineers must maintain a life cycle viewpoint as they design products. Yun yung na-discuss natin last time, yung tungkol sa life cycle. Kumbaga sa simula hanggang dulo, i-consider ng isang engineer kung magkano yung mga gastos or perceived na magiging gastos dun sa buong economic life ng isang equipment or isang machinery. Such a complete perspective ensures that engineers consider initial investment cost, operation and maintenance expenses, and other annual expenses and later years, environmental and social consequences over the life of their designs. So yun ngayon na-discuss natin na sa buong life cycle, yung initial investment cost pa lang, yung operation maintenance cost, tsaka yung annual expenses in later years. So itong mga to, di-discuss pa natin, may mga topics pa tayong magtatakal pa rin dito sa next lectures natin. Yung annual expenses, lalo na sa yung tinatawag nating annuity. Tapos ngayon, dapat i-consider na rin natin yung environmental and social consequences ng mga dinedesign natin over the life ng design natin. Kung familiar kayo dun sa tinatawag na green engineering, sa civil engineering, so meron ito sa construction, lalo na sa pag-design din, sa architecture. Sa civil engineering, yung ginagawa dito yung sa materials na ginagamit, tsaka yung way ng pagko-construct. Pwede rin sa ibang field, sa pag nabubuo tayo ng isang product, or ng isang system, dapat ma-ensure natin na hanggat maaari ma-prevent yung pag-develop ng waste, yung pagpili ng materials. So dapat sumusunod din sa concepts ng green engineering, tsaka yung reuse and recycle ng resources. So for cost-driven design optimization problems, so yung two main tasks are as follows. Number 1, determine the optimal value for certain alternatives design variable. Kung ano yung kailangan natin or yung pinaka-efficient na kailangan nating requirement para dun sa isang design variable. Depende, for example, sa civil engineering, kung naaalala nyo or kung na-discuss na sa mechanics of deformable bodies or sa fundamental frigid bodies, ang kino-consider natin dun is yung strength ng materials. So, pwedeng i-relate natin yun sa pwedeng thickness, sa type ng material. Since kung anong kailangan natin, pwede rin sa strain, para malaman natin kung ano yung allowable strain para dun sa isang material or isang part ng isang system natin. Next ay yung select the best alternative, each with its own unique value for the design variable. Syempre meron tayong mga alternatives, so pipili tayo dun kung ano yung pinaka-efficient based dun sa naset nating optimal value para mapunan yung requirement na sinet natin. And in general, the cost models developed in these problems consist of 3 types of cost. So yung mga na-discuss natin dati, yung iba't ibang klaseng cost sa cost terminologies, i-consider natin ito dito. Number 1 is yung fixed costs. Costs that vary directly with the design variable at saka yung costs that vary indirectly with the design variable. So, simplified format of a cost model, yung pinakasimple dahil based dun sa nilagay natin na mga types ng cost na dun sa mga problem natin. So, cost is equal to A times X plus B over X plus K. In which yung A, yun yung parameter na nagre-represent ng directly varying cost. Yung B, indirectly varying cost. Yung K naman, yung nagre-represent sa fixed cost. And then yung X, yung nagre-represent sa design variable. Pwedeng yung mga parameters na sinet mo, kung directly or indirectly, pwedeng in terms of weight or velocity. So, depende rin kung gaano ka-komplikado yung mga parameters na naset mo or mga design variable. Pwedeng yung value for X naka-raise pa to some powers or mas komplikadong cost model. Para yung pinakasimpleng model at na yung present dito. So, next ay yung the following steps outline a general approach for optimizing a design with respect to cost. Number 1, identify design variable that is the primary cost driver. Pwedeng yung, for example, yung pipe diameter na magbibigay ng required strength, required rigidity. And the next ay yung write an expression for the cost model in terms of the design variable. Yung na-discuss kanina, yung tungkol sa cost, tapos i-relate natin siya dun sa design variable mo. So number 3, i-differentiate lang. Number 4, solve natin kung ano yung magiging minimum values or para makuha natin yung optimal value. Number 5, check natin kung yung ba nakuhang sa first derivative, kung yun ba yung maximum or minimum Kung naalala niyo sa differential calculus, kung paano malaman kung maximum ba or minimum yung first derivative, kung increasing or decreasing yung rate of change. So, dun yun papasok. Okay, sample problem. The cost of operating a jet-powered commercial or passenger-carrying airplane varies as the three halves power of its velocity. Specifically, C sub O is equal to K N V raised to 3 halves, where N is a trip length in miles, K is a constant of proportionality, and V is the velocity in miles per hour. It is known that at 400 miles per hour, the average cost of operation is $300 per mile. The company that owns the aircraft wants to minimize the cost of operation, but that cost must be balanced against the cost of the passenger's time. So, dinote dito yung CC, which has been set at $300,000 per hour. At what velocity should the trip be planned to minimize the total cost, which is the sum of the cost of operating the airplane and the cost of passenger's time? Okay, solve na natin. So, the cost of operating of jet power. Okay, record natin at velocity to minimize the total cost, which is the sum of the cost of operating the airplane and the cost of passenger's time. Okay, so kunin natin yung total cost. So, minimize yung total cost. Gawa tayo ng equation in which kasama yung total cost tsaka yung velocity. So, in total cost, pwedeng sabihin natin na yun yung CO at tsaka yung CC. In which yung CO, yun yung sa cost of operation. Equal daw yun sa K and V raised to 3 halves, in which yung K, constant of proportionality, and then yung N is trip in miles or trip length per mile, in miles, and then yung V, yun yung velocity. In miles per hour. Okay, tapos yung sinabi pa na yung kapag daw at 400 miles per hour, average cost of operation is $300 per mile. So, pwedeng kunin natin yan, no? So, at velocity is equal to 400 miles per hour. Cost of operation or average is equal to 300. Okay, so try na solve natin dito yung in terms of CO. So at velocity is equal to 400. So CO is equal to K and V raised to 3 halves. CO is 300. K, yun yung hahanapin natin. N, assume natin na 1 mile. So, yung V, so lagay natin na 400 raised to 3 halves. So, miles per hour and then mile. And then R yung unit nito. Solve natin yung K. So, 1 mile to. Ito ay miles per hour. And then ito ay naka-Rs or dollars per mile. So, solve natin yung K. So, K is equal to 300 over 400 raised to 3 halves. So 380. 3 over 80. So yung unit natin, simplify lang natin to, no? So 300 miles or dollars per miles. Dollars per mile. So equals sa K 1 mile. Tapos ito, unit natin dito, miles per hour. So raised to 3 halves, so makakancel yung mile. So matitira na lang sa K, hours per mile raised to 3 halves. Okay? Next naman, kunin natin yung sa cost of passengers time, in which yung sa CC. So yung CC, pwedeng gawin natin na $300 $400,000 per hour. So kunin natin siya in terms of sa ratio ng total miles travel at saka yung velocity. Kumbaga time yung kukunin natin, no? Dahil sabi nga distance or velocity is equal to distance over time. So kung 300,000 per hour, $1,000 per hour. So kailangan natin dito ng unit na R. So total time of travel. So total time of travel related yun sa velocity at saka yung sa distance traveled. So pwede nating sabihin na dahil yung distance pala natin dito, dinenote natin yun as N. Or so pwedeng lagay na lang natin dito na so N to na, and then yung kailangan natin, so N over natin to. So T is equal to N over V. So N over V. Okay? So yung in-assume natin dito is 1 mile. Kaya lang, para makuha lang yung constant of proportionality. So solve natin. So CO is equal to, or CT, total cost, is equal to C sub O plus C sub C. And then yung C sub O, yung of operation, yung K and V. So ito, makuha na natin. So yung K natin, 3 over 80 hours per mile raised to 3 halves. Yan yung K, and then N, and then velocity, plus yung C sub C na 300,000 N over V. So ang sabi doon, yung next step, di-differentiate natin. I-differentiate muna natin, kunin natin yung first derivative. So in terms dun sa kailangan nating malaman na value dito, no, at what velocity para ma-minimize or ma-maximize yung kailangan natin, yung cost. So in terms of V, yung V natin pala dito may 3 halves span. So solve natin, 3 over 80. So ito, 3 halves. So 3 halves. Then yung unit natin, hours, miles raised to 3 halves. And then N. And then yung V. So yung kailangan natin. And then minus 1 dito. So 1/2 na lang to. Plus. So dahil ito V, nasa baba, pwedeng ilagay natin to dito, no? V raised to negative 1. So mangyayari, negative 1, then 300,000 multiply sa N, and then V minus 1, or negative 1 minus 1, so negative 2. So equate lang sa 0. Simplify pa natin. So 9 over 160 and V raised to 1/2 plus or minus 300,000 and V raised to negative 2. And then pwedeng i-divide natin both sides by N. So makuha na natin yung value for V. Pwedeng gawin natin, multiply natin both or yung buong equation para mas simple, no, sa V squared. So simplify muna natin. So 0 is equal to 9 over 160. And then V raised to 1/2 multiply ng V squared minus 300,000 V raised to negative 2 multiply sa V squared zero is equal to 9 over 160. 1/2 plus 2 is equal to 5 over 2 minus 300,000. Negative 2 plus 2 is equal to 0. So 1 na lang yan. So add natin both sides by 300,000. Then makukuha natin na yung V raised to 5 over 2 is equal to 300,000 and then multiply both sides sa 160 over 9. Yan. Tapos raise natin sa 2/5. Therefore, V is equal to raised to 2/5. Yung sagot natin ay 490.68 miles per hour. So ang next natin i-discuss, doon na tayo sa present economy studies.